Welcome back, Stupid Fast Nation. How are you guys doing today? Taking a break from the building this week as I'm waiting for some parts for the YFZ 450 and the Banshee Swap Kids Quad. If you guys are interested, I'm willing to teach you guys what I know about two-strokes and how to get the max performance out of your two-stroke engine. So I'm gonna give you 10 top tips, cheap and free ways to get the most power to your two-stroke. And if you stick around, I've got a bonus one. So I'm gonna try and keep this as clear, concise, and quick as possible. I've literally got a list in front of me of my top 10 things so that I could hit them as fast as possible for you guys. So we're gonna start with jetting. Jetting, I feel, is one of the most important things in a two-stroke that is going to give you your mix of your air and fuel, as well as your mix for your fuel and oil, which is the lubricity for a two-stroke that has a closed crankcase engine. So, with that being said, most of the focus on this is going to be within a reed valve style two-stroke engine. There are different types of two-stroke engines. There's piston port, there's reed valve, there's rotary valve, and there's a few others that I'm not gonna hit on in this video. So typically with a two-stroke, being leaner on the jetting, that means the smallest size you can go without incurring detonation within the cylinder is where you want to be. The richer you go, the more power you're going to lose as a whole, but the more reliable and safer it will run. So if you're not worried about the max performance and you want to be out on the trails ripping around for a long time, the most oil that you can get in the cylinder with your jetting and your fuel and oil mix is going to be what you're going to want to shoot for. So bigger jetting, more fuel within the mix. The leaner you go, the more power you're going to have, but the more longevity you're going to lose in the long run. So the life of the engine definitely won't last as long with these methods, but you'll get peak power out of it. Then we're gonna move on to ignition timing. Ignition timing is another cheap and easy way to get the most power out of your two-stroke engine. There's a few ways you can do this. Some aftermarket manufacturers offer different ignition units for your two-stroke engine. The Banshee, they have like a Dyna ignition. Banshees happen to be one of my favorite two-strokes. And you know, as you guys can see, I have tons of Banshee stuff behind me, RD350, R5, RZ350, RZ500, stuff like that. So ignition timing is going to be the second tip that I'm gonna give you guys. That is another way that is cheap or free to gain the max power out of your two-stroke engine. So ignition timing. Some engines have a plate where you can loosen screws and turn the side of the stator to be able to advance or retard the timing. The most advanced you can get without having detonation in the cylinder, that's going to be what you're going to want to shoot for, because that's going to give you the most amount of power. The idea of ignition advance is to hit the spark right as the piston comes to top dead center. The faster that rotating assembly goes, the further away the spark becomes, and it actually becomes retarded through mechanical and electrical difference. The more retarded the timing is, the more power you're going to lose. Most cases for this, guys, most cases, that's really, really important. So that's important on naturally aspirated, because when we get into stuff like forced induction and nitrous, ignition timing plays a completely different role in an engine that's set up like that. It's a whole different animal. Then we move on to exhaust systems. Exhaust systems are extremely important. You have the expansion chamber size, which is going to be dependent on the amount of basically volumetric efficiency of the cylinder is going to be using. That's bore size and stroke. And so the expansion chamber size is going to be really important. The length of the entire exhaust is going to be really important. The inner diameter of the flange that goes to the cylinder is going to be one of the most important things. And then whether or not you have a silencer or a stinger. You want the biggest bore expansion chamber possible without overflowing the engine's flow capabilities. There's a lot of mathematical calculations, but you can play around with a lot of this and get into a good range without spending a lot of money. Changing the inner diameter of the flange for the exhaust side is also another way to gain power, so you have to be careful and play around with this stuff a little bit. Then obviously you have other factors like the silencer makes it quieter for guys that like to be out in, you know, state wooded areas and stuff like that, or if you're in town and you don't want to be that loud, obviously drag pipes aren't the best solution for you. You can have a silencer and still make a lot of power. That is why the flange diameter as well as the expansion chamber are your most important things. Next up is Squish Band. I think this one is left on the table far too much. From the OEM manufacturer, a lot of times the engine isn't blueprinted properly. It leaves a lot of room for error, especially in two strokes. When you get to the squish band, that is the amount of space you have between the top of the piston and the dome of the head. Not the actual dome where the spark plug is, but the band around the outer circumference of the piston itself. So the area between the piston and the cylinder head, that's called your squish band. What you want is the tightest squish band you can get before the piston hits the cylinder head itself. So you can actually change things like the base gasket of the cylinder head gasket thickness, and you can also shave off top of the cylinder head itself. You can shave the piston, you can shave the cylinder head to get the minimum clearance that you can. There's a lot of calculations out there, so I'm not here to give you guys exact specs on what that clearance needs to be, because every bore, every stroke, every motor is going to be different, especially dependent on your application and fuel type. The idea is if the piston has too much clearance between the edges of the piston and the squish band itself, what will happen is you will actually create detonation because gas gets trapped in there and it becomes highly combustible when that area is left open enough for fuel and air to enter in there. So we try to close that gap as much as possible to get the end gases out of that area. This will decrease detonation, raise compression, and increase horsepower as a whole. This will also lengthen the life of the engine, believe it or not. Then we move on to one of my favorites, porting. Now, I'm not gonna get into detail with how to port the engine. I'm actually gonna do a whole separate video on that at some point. But porting a two-stroke is by far one of the biggest things you can do to gain horsepower. There's a bunch of different ways to port the engine. Changing your port timing, as well as gasket matching. Gasket matching is a nice, cheap, and free way. You could take your base gasket and you can match it up to your transfer ports and actually port that out so that that matches the cylinder. And then you can also do that with the intake and exhaust as well. Make sure the exhaust flange, the diameter, the inside diameter matches the exhaust, as well as the intake gasket and the intake itself. There's no edges or anything on the inside. That's all ported out so the flow is nice and smooth in and out of the cylinder. These are free ways with just a porting tool and a little bit of knowledge that you can get free horsepower out of your two-stroke. There's also another thing you can do by putting a base plate underneath the cylinder and then milling off the equal amount off the top of the cylinder to change your port timing. This can increase power, but you have to know if you go too high, your exhaust gets so high that you actually start to lose compression. And yeah, the motor will run really high RPM, but you'll lose power if you go too far. So you have to be really careful with port timing and porting on your two-stroke. Then we can get into fuel types. We have, your 87 to 93 octane pump gas, which is good for trail bikes and ones that you want to run for a really long time without having issues. So you're not going to go like super high compression race motor running on pump gas. You can't have a lot of compression or else you're going to have detonation issues. Then we move on to race gas. It's really, really expensive and it uses only a little bit more than regular gas and it doesn't incur as much detonation as regular gas. But one of my favorites is we get into the E85 methanol and alcohol fuels. Those types of fuels will actually require about 30% more fueling in most applications. This is all dependent on the motor size, but 30% is a good base figure. So if you upjet about 30%, you should be good to go. The other benefit to E85 methanol and alcohol fuel is that it actually cools the cylinder down so that your engine temps run much lower. I know it sucks that it costs a little bit more in fuel consumption, but the fuels itself actually don't cost more than race fuel. Like race fuel is actually 10 times more expensive. A 5-gallon drum of race fuel is like 140 bucks these days, where a 5-gallon pail of E85, 5 gallons for less than 20 bucks. So there's a significant difference in price. Methanol in a 5-gallon drum is about the same. It's like $4 a gallon. Alcohol can be a little pricey depending on what you get. And then you have to be careful what kind of oil you mix with it, because only certain premix oils can go with E85, methanol, and alcohol-based fuels. The other factor is you have to clean the cylinders and everything out when you're done, because methanol is a fuel that actually eats things away if you leave it in there. It's very corrosive, so you should clean that out. So a lot of guys will have race fuel on standby, and when they're done racing, they clean them out. Another huge benefit to running E85 methanol and alcohol-based fuels is that you can run a lot more ignition timing because of that cooling effect it has. So there's a lot less heat in the cylinder and you can run that ignition timing, make a ton more power, a lot more safely without incurring detonation. If you're wondering if you're too high of compression or anything like that for a certain type of fuel, there is calculations all over Google for you to see. My base number is about 160 pounds of compression. If I get above 160, I start running like 100 plus octane of fuel. Then I go to the calculations and look up what I need. Underneath 160 pounds of compression, I just run 93 to 87 octane fuel. We can get into the volume of the cylinder and bore. We could talk about stroke and bore. Those can get a little pricey because then you're talking about machining costs, aftermarket cylinders, stroker cranks, having cases trenched, and all these other aftermarket modifications you have to do, but those are big power gainers. If you do a big bore, big stroke, you can gain a ton of horsepower. I know it's a little bit more pricey, but it's a lot easier to gain that power that way. Some of the benefits of having big bore, big stroke are that you're gonna gain a ton of horsepower. Yes, you're going to lose a lot more fuel a lot faster, but it's worth it for the horsepower gain, in my opinion. Less bore and less stroke is okay, and you can still get a lot of horsepower, but one of the benefits to having a smaller bore, smaller stroke is that you have a lot less rotating mass, in which case the engine will typically rev much higher than its big bore, big stroke or counterpart, where you will start to lose RPM in the larger engines. This is even in today's production vehicles. When we talk about like R1 versus R6, street bikes, the RPM difference is like 3,000 RPM because the rotating mass is that much more. And the cool thing about most two-stroke ignitions is the only thing that limits you is your mechanical limit. Most of the ignitions, the electronic side will go as far as it can electrically. The mechanical limits of the engine will be where it actually ends. There's no actual rev limiter on them. Another big benefit to big bore, big stroke is it will create a ton of bottom end torque, where two strokes seem to lack in that department a lot. Well, when you start adding that big bore, big stroke, you start adding a ton of torque to your plate, which can be great, especially if you're lacking mid-range or if you have the type of porting that only supports high RPM. It's nice to get a little bit of your torque back. Moving on, let's talk about carburetor and intake size. Carburetor flow is extremely important, and going bigger is definitely necessary. Your engine is like an air pump, and the faster you get the air and fuel in the engine and out of the engine is the more power that you make as a whole. So obviously going with a bigger carburetor and a bigger intake is going to increase that flow. The problem is a lot of guys actually get into over airflowing their engine, where they create so much of an airspace by going with too big of a carburetor that they overflow the engine and they can't give it enough fuel because the efficiency of the motor doesn't need that much air. So you have to be careful and you have to size your carburetor and intake properly. Then we move on to spark plug type and gap. Spark plug is something that is very much overlooked in a lot of areas of performance. I definitely don't think you should overlook spark plug type. I know a lot of two-stroke guys, all they run is a BR8ES in a lot of their two-stroke motors, and that's a great plug, don't get me wrong, but you can do better if you dial in your spark plug. Spark plug and spark plug gap are extremely important. If your gap is too big, you can actually blow the spark out before the piston even comes all the way up and it gets to ignite the mixture, and then you can have misfires and other things and you'll be chasing your tail. So gap is extremely important. There's lots of helpful stuff on the internet. All you gotta do is look for it. Then we talk about heat range of the plug. So not only the gap, but also the heat range is extremely important. The heat range is the third number in, so BR8, 8 is your heat range. You could try a 7, you could try a 9. The motor's gonna tell you what it wants, and you can look up what a plug chart and do a plug chop on these bikes, and that way you could determine what heat range is best for your bike. Different elevations, different atmospheric pressure, different temperatures. This is all going to determine what type of plug you should be running. Fuel type, the amount of oil you're putting in it, your porting, all of this stuff's going to change with each and every motor. So it's very important to play around with some of this stuff. Spark plugs aren't that expensive yet, so it doesn't hurt to buy a couple extra, go hit the trail with some jets and see what's going to work best for your bike. Then last but not least, I want to talk about fuel and oil mix. A lot of guys don't get wrapped up in fuel and oil mix for a multitude of reasons. In my opinion, that is one of the most important things when running a two-stroke because the oil inside the gas is what lubricates the crankcase and gives all those parts the oil that it needs to rotate. Too much oil and you'll foul spark plugs and it won't want to run right. Too little oil and you'll be lean and you can detonate, and too much friction from the components not being oiled properly will actually kill the horsepower. Now that we got my top 10 out of the way, let's give you guys a bonus one. So we talked about reeds a little bit earlier. I talked about intake, carburetor, porting, all that stuff in between, but I didn't talk about the reeds themselves. Reeds are extremely important. They are what control the flow coming into the cylinder. So the size of the reed cage, as well as the restrictor plates. Most stock reed cages come with restrictor plates on the outside. One of my favorite things to do is cut the restrictor plates off. I have learned recently this is not good on all two-stroke motors. Somebody who's going to be watching these videos is going to know exactly what I'm talking about. But you don't want to always cut the restrictors off. Sometimes you can bend them out slightly. Most of them are bent enough to go to the outside of the inside of the intake, but I cut them off on open air two-strokes like a Banshee. I learned recently you can't do that on boat motors. It's not a good thing to do on boat motors because the reeds don't close in time and they pull water back into the cylinder. So you can cut the restrictors off, or you can order aftermarket reeds like Boyson. They make reeds for almost everything. My Banshee, I run a Chariot cage, which has the most open flow that I could find on the cage itself, and then Boyson rad valve reeds, which open up all the way, and this thing freaking screams. So no restrictors, they just have a plate and a set of reeds, and then a little steel plate at the bottom with no restrictors, and that's how they come right in the box. So from the factory, what you can do is actually cut those restrictors off. It will let the reeds open up all the way and will give you max flow. You have to be careful with this though. Sometimes the reeds will not bend all the way back over time, and then they'll have little gaps, which can make idling and tuning very difficult. So that's why it's better to just go buy aftermarket reeds and an aftermarket reed cage, or a complete unit like your, V-Force 4 reeds or V-Force 3 reeds, or whatever the current is on the market that is the best for your application. So just keep in mind, guys, the quicker you can get fuel and air in and out of the cylinder, the more horsepower you're gonna make. If you guys like this video, you want to see more like it, give me that like, share, subscribe, comment below on more videos you want to see like this. I'll do a 4-stroke at some point because I do play with everything, turbo, nitrous, 2-stroke, 4-stroke, rotary, you name it. I love to build, you guys already know that. And in the next video, I'm going to be tackling the YFZ 450, and then I'm putting a CBR 600 motor into an ATC 250R, which is going to be very exciting because that thing is gonna rip. See you guys in the next one. Peace out.